In today's video, we're going to take a look at applying the things that we've learned about linear equations and graphs to specific examples where we're going to look at trends, trend lines, scatter plots, and real-world world problems. If we take a look at our first topic, we're going to explore scatter plots. You've seen scatter plots before, but by definition, a scatter plot is a graph that relates two different sets of data by plotting the data as ordered pairs. So I've plotted three different examples, and each of them has a different correlation. If we take a look at the first one, each of these lines, or each of these, points, tend to be going in the same upward direction. This means that I have a positive correlation. If I wanted to represent that with a trend line, and notice below, a trend line is a line that approximates the relationship between the data sets on a scatter plot, and we can use this to make predictions. I can write or draw a trend line by trying to draw a straight line through as many points as possible. So my trend line would be here, and it's going through a few points that I could use to write an equation if I was asked to. If we take a look at the next example, these points, they tend to be scattered a little bit more, which is fine. It just has a slightly weaker correlation, but the trend is down. And so this would be a perfectly straight line, but I would have a few points on here that I could circle, and my points tend to be going down. This means that I'd have a negative correlation. Another way to look at correlation is as my x values are increasing, so are my y values, and so this is a positive correlation. Suppose that here, as my x values are increasing, my y coordinates are decreasing. That's why we have a negative correlation. On my third one, I can't tell whether I'm going increasing or decreasing. There'd be no line that would represent the general trend of this, and so there is no correlation for this example. Okay, let's apply this concept to our first example. Here we're being asked, to graph these ordered pairs and to then determine whether a linear model is reasonable, and if so, to draw a trend line and write the equation. Okay, so I'm going to put some tick marks in here. Okay, and I need to plot each of these. Okay, 0, 2, to the right 0 and up 2. It's going to give me a point right here. Okay, to the right 1 and up 3, to the right 4 and up 6, okay, and to the right 5 and all the way up 8. Okay, these points, while they aren't in a perfect line, they do have a positive correlation, meaning that I could draw a line that would go through each of these, or as many points as possible. So I could draw a line as straight as possible, again, straighter than mine, using a ruler that would go through at least 2 points. If I take these 2 points, I can write those two. Specifically, I've chosen 0, 2 and 5, 8 because they happen to fall on my line. If I need to write then an equation, I'm going to need to go back to what I've learned before about how to write an equation for a linear model where I'm being given 2 points. To do that, first I need to find my slope. So to find my slope, I subtract my y values, 8 minus 2, and I divide that by the difference of my x values, so 5 minus 0. And I end up with 6/5. This is my slope. I'm going to use my y-intercept, my b value, or my point. My ordered pair that I'm choosing is 0, 2. And so I'm going to use my point slope form, y minus y1 equals m times x minus x1. Okay, I'm going to substitute in my y1 value is 2, so y minus 2 is equal to my slope, 6/5, times x minus my x value, which is 0. And I get y equals 6/5 x plus 2. Technically, I did not need to use point-slope form. Since the point I chose was a y-intercept, I could have just put 2 at the end. But that's only the case when I'm given a y-intercept, which is why I chose to do this example with point-slope form. Typically, you'll end up using point-slope form. So to answer my question, determine whether a linear model is reasonable. My answer is yes, it is reasonable. If so, draw a trend line. This line that I drew is my trend line. Okay, and then write an equation. My final equation that I needed to write is right here. Y equals 6/5 x plus 2. Let's take a look at example number 2. A candle is 6 inches tall after burning for 1 hour. After 3 hours, it is 4 inches tall. How tall will a candle be after 5 hours? And then how tall was the candle when it was first purchased? Okay, I need to interpret this. So I'm going to let my x variable represent time. And specifically, it's going to be time in hours. And this tends to be the case that my independent variable, my x variable, is time. Okay, my y is going to represent the height of my candle. And in this particular case, it's going to be in inches. So if I go back up to my original problem, I have a candle that is 6 inches tall after 1 hour. That's going to give me the ordered pair 1, 6. If I take a look at my next part, after 3 hours, it's 4 inches tall. That's going to give me the ordered pair of 3, 4. And let's take a look then. Based off of this, I want to know how tall it will be after 5 hours. Well, before I can answer that, I need a linear model. So my first step is to find a linear model that goes through these 2 points, 1, 6, and 3, 4. Okay. Again, to do this, I'm going to find my slope. When I subtract, I have 4 minus 6 on the top for my numerator, or the difference of my y's, divided by 3 minus 1. 4 minus 6 is negative 2. 3 minus 1 is 2. So my slope is negative 1. With m being negative 1, I have a slope. I need a point. I'm going to choose my first point, 1, 6. So I'm going to do y minus 6 equals my slope of negative 1 times x minus my x value, which is 1. Distribute, and I get negative 1x plus 1. And then if I add 6 to both sides, I get negative 1x plus 7. Okay? Based on this, now I want to find out what the candle would be after 5 hours. Well, 5 is an x value. So I'm going to substitute in x for 5. So I have negative 1 times 5 plus 7, and that gives me my y value, which turns out to be 2. This tells me that after 5 hours, the candle was 2 inches high. So I would write that out. First answer, after 5 hours, the candle is 2 inches tall. Right? They also ask us, how tall was it when it was first purchased? Well, when it was first purchased, this would tell me that I want to find out when my time, my x value, is equal to 0. Well, x being equal to 0 is the same as my y-intercept. My y-intercept is 7. So the candle was 7 inches tall when it was first purchased. Hopefully this video has given you an example or a few examples as to where you can apply your skills of being able to write linear equations and then how to apply them to make predictions for how much it will be after 5 hours and to interpret your graphs.